Yes, at this point balancing factor is violated. Now tree becomes 15, 8, 18, 5. So move towards right direction. Now tree becomes 12, 13, 14. Then what is the connection? 9. $54. Fine. So here first step has been completed in RL rotation, right? So then once we can get the tree, we can apply second step for this one for 8, 12, 13 nodes. So once first step completed in RL rotation, then it forms the RR rotation. It forms the RR rotation, right child of right subtree. So simply it moves towards left direction. Towards left direction. Now tree becomes 15, 12, 8, 5, 18, 54. So 12 is moved, 5, 13, 14, 13, 14. Then so 9 is placed at this one. So here once we can place, it should not violate the binary search tree property, right? Once here this can be placed at this position, binary search tree property is violated. So that's why, so 12 child of 12 is 9. So 9. So here after moving left position, so 12 contains 2 children. So that's why here I am placing 9 child of 8. Right? Now to check whether the tree satisfies the balancing factor property or not. 0, 0, 0, 0. For this 1 minus 1, 0. For this 0 minus 1, minus 1. For this 2 minus 2, 0. For this one 0 minus 1, minus 1, 1, 2, 3. So 3 minus 2, which is equivalent to 1. Right? So here balancing factor property has been satisfied by this tree. Now this tree becomes AVL tree. So what is the next inserted node? So 9 is inserted, then 61. So 61 in step 10, 61. So 61 is greater than 15. Obviously we can place it at the rightmost position of 54. When compared to 54, 61 is also greater, right? Now tree becomes 15, 12, 18, 8, 13, 54. This is 61. 14, 5, 9. Fine, na? So 5, 9. So here after insertion, this tree has been affected. So binary balance factor for this same 0, 0, 0, minus 1, 0, 0. So now we are calculating 0. So this is 0, minus 1, minus 1, 0, minus 2, minus 2. So here 1, 2, 3, 1, 2, 3, 3 minus 3, 0. So here balancing factor is violated at this node by inserting right node of right subtree. which is nothing but RR rotation. So in RR rotation, what we are doing? Simply we are moving the node towards left direction. Now tree becomes 15. This tree is same, 8, 13, 5, 9, 14. This tree is same, only this tree is affected, right? So balancing factor is also same, -1, 0, 0. Fine. So here moving towards right direction, left direction, sorry, left direction. Now tree becomes 54, 18, 54, 18, 61. Now we are calculating balancing factor 0, 0, 1 minus 1, 0. So here 1, 2, 3, longest path, 3 minus 2, 1. So now balancing factor property has been satisfied by this tree. So that's why this is also AVL tree, right? What is the next inserted element? So after inserting 61, we are inserting 20. Step 11. Step 11. I am inserting inserting 20. So 20 is greater than 15. Obviously, it can be placed at right subchain. When 54, it is less value, move to 18. So when compared to 18, this is greater value. So that's why you can place it at right of 18. Right? Now tree becomes 15, 12, 54, 8, 13, 5, 9, 14. Fine. Then 18, 61. So we are placing 20 at right of 18. Right of 18. Right? So now check the balancing factor for each and every node. 0, 0, 0, 0, 0. For this one, 1 minus 1, 0. For this one, 0 minus 1, minus 1. For this one, 0 minus 1, minus 1. For this one, 2 minus 1, 1. For this one, 2 minus 2, 0. For this one, 1, 2, 3, 1, 2. 3 minus 2, which is equivalent to 1. So here balancing factor is not violated. This is also a AVL tree, right? So after inserting 20, we are inserting one more node, that is 17. 17. So 17 is greater than 15. So that's why we can place that right subtree at this position. Left of 18. Now tree becomes 15. So in step 12, 15, 12, 54, 8, 13, 18, 61, 5, 9, 14, 20, 17. So here 17 is inserted at this position. Why? Because when compared to 54, this is less value, then we are moving left side. When compared to 18, this is less value. That's why we are placed at child of 18. Right? Now we are calculating the balancing factor 0, 0, 0, 0, 0. So 1 minus 1, 0, 0 minus 1, minus 1, 1 minus 1, 0, then 0. We are calculating 2 minus 1. 1, 1, 2, 3. 3 minus 2. 3 minus 2, 1. For this, 2 minus 2, 0. This is also satisfies the AVL tree properties, balancing factor property. So that's why this is AVL tree. Then what is the next inserted value? 21. So in step 13, we are inserting 21. So 21 is inserted at right subtree, right of 20. Right now tree becomes 15, 12, 54, 8, 13, 18, 61, 5, 9, 14, 17, 20, 15 to 12, 8, 13, 54, 18, 61, 9, 13 to 14, 17, 20. So we are inserting 21. We are inserting 21. So when compared to 54, this is less value, then we are go to 18. So when compared to 18, 21 is greater value. So 21, so that's why we can move right position. So when compared to 20, this is also greater value. So we are calculating the balance factor for each and every node. 0, 0, 0, 0, 0, 0. For this node, 0. For this node, 0, minus 1, minus 1. For this, 2 minus 2, 0. For this one, 0, minus 1, minus 1. For this one, 1 minus 2, minus 1. So here, this one, 1, 2, 3. 3 minus 1, which is equivalent to 2. Then we are calculating this one, 1, 2, 3. 3 minus 2, which is equivalent to 1. Now balancing factor is violated at this node. We are inserting right of left subtree. Right of left subtree, that is nothing but LR rotation. So here in LR rotation we are applying two-step process. Now tree becomes so balancing factor violation is done at left of right child. Right? So we are applying LR rotation. So in LR rotation, first step we are move left direction. So here this node is moved left direction. Now tree becomes 15, 12, 54. So this tree is not affected. So same tree has been written. 8, 13, 5, 9, 14. So here I am moving this node. Now tree becomes so LR rotation 20, 18, 17, 20, 18, 17. This is 61. This is 21. What are the three nodes? So here these are the three nodes. So after first step has been completed, then LL rotation is applied. LL rotation is applied in LR rotation. That is the second step in LR rotation. So after apply LL rotation, the node move towards right direction. In LL rotation, the node move towards right direction. Right now, tree becomes 15, 12, 20, 54, 61. So this tree is same na 8, 13, 5, 9. So 20 is moved, 54, then 18, 20 is moved, 17, then 21. So 20 node already contains children, so that's why this node is placed at this one. Then only we can satisfy the binary search tree property. So when compared to 20, 21 is greater, so that's why compulsory we are placing at right subtree, right? So here again we are checking the balancing factor for each and every node. 0, 0, 0, 0, 0, 0. 1 minus 1, 0, 0 minus 1, minus 1. Then this is 1 minus 0, 1, 1 minus 1, 0. For this 2 minus 2, 0. For this 2 minus 2, 0. For this 3 minus 3, 0. Right? So after completion of all insertions, the tree satisfies the binary search tree property as well as balancing factor property. So that's why the final tree is said to be AVL tree, right? So this is about insertion operation. If you have any doubts regarding to this session, please post your doubts in comment section. Thank you.